Okay, so we've looked at sequences, yes. So how we would generate them. So if we've been given a rule, we can generate the sequence by, remember, substituting in values for n. So if we wanted the first term, we put n as 1, second term as 2, etc., etc. And we've also looked at describing them with words. So the pattern starts at the number 5, and we add 4 each time, etc., etc. And then we've also done the nth term. Do you remember we used UN to show it's the nth term? Did I tell you that? UN? UN. Now, I don't know if I did tell all of you. Some of you, when it came to the questions, you saw that it said something like this. And I was explaining that that just means the nth term. It's a fancy way. I don't know why they use the letter U, but it's just U, and then it's subscript N.
Like
Yeah, a bit like that. So that's what we've been doing up until now. Now, remember, how do we find those nth term rules? What do we do to find the nth term? What's our first step? Georgie?
you see it, how many times
Yes. And what's the fancy way of describing that? Rather than what it skips. Good go. It's the difference. So we find the difference between them. And then that number is always attached to which part of our rule? So do you know that? So the difference. So if there was a gap of 4 in between each of the numbers, how would our rule start off? So if we had this is our, let's start with. So if this was our sequence, okay, so I can see there's a gap of 4 in between each of them. How would I start my rule off? What would my rule be? What importance does this number 4 have for the nth term? I'm trying to find the nth term. N goes in front of the n. Good girl. So that would we would write 4n. Yes? And then Sarah, how do I know what goes on the end here, if anything? How do I know what would go there?
You would plus but oh no, you would take away from the last one.
Let's read the last one.
You would take away from 7.
Do you mean secretly the first one? Yes. So remember this was our first term. So what we would do is we pretend we were looking at the one before that. Yes? So what would the number in the sequence be before that one, Jake?
Plus 3.
Plus 3. And so we're going to write plus 3. So our rule for this particular pattern would be 4n plus 3. Yes?
Yes.
It's all familiar? So we look for the difference. The difference goes in front of the n.
We're on our notes pack, right?
Yes, definitely. And nothing I've said is on your notes pack. This is just a quick recap.
What page are we on our notes pack?
It's a single page note.
I'm still writing this down.
What? You can do if you want to. It's just a recap. We've got everything written down somewhere.
Oh, I got it.
Okay? So, that was just a recap of everything we've done until we've done up to now. Do you have a question there?
No.
You sure? Alright, so that's a recap. Now, what we're going to do today is look at something a little bit different, but it's in the same family as it. So if we're given a rule for a sequence or a practical situation that you are asked to graph, you need to generate coordinates and then plot them on a graph. Now, what on earth is this woman talking about? Well,
Graph.
all it means is that remember we were saying you've got a rule that it's, for example, well, let's go back to that other one, 4n plus 3. That's my rule. And if I ask you to graph that, you might think, well, how on earth am I going to do that? Well, all you would need to do is to generate points. So we'd say, what would the first term be? How would we find the first term? We've already discussed this once already today. Abby, how would I find the first term in this sequence? If I was just given the rule for it. Just explain to me how to do it.
Sorry, 1 second. Come back to this.
Well, it said, no, come back to the situation. And squared?
So what you do is you substitute the n for 1, and then you 4 times 1 is 4.
Good, so our first term would have been 7. And then, okay, Abby, how would I find the second term?
4 times 2, which is 8, plus 3,
Which is?
11.
Good go. All right, so we've generated some numbers. Now, the link here is that this number here was our first term. This number here was our second term. So we're connecting these numbers here. So it's 1 goes with 7, 2 goes with 11, and so on and so forth. Do you understand what I mean?
Mm-hmm.
Right, we'll do some more examples in a minute. Okay, so I've said here, you should identify which of the things you are plotting is the independent variable and which is the dependent one. Now, I'm hoping that you're sitting there going, oh, we've heard all about that in science. Have you heard or the phrases independent and dependent variable in science? Is there anyone that has not heard it before? I'm not asking if you know what it means. All right, so let's just clarify what it means. So, the independent one is the one that usually increases by 1 each time. So, for example, in this case, it would be the term number. So, term 1, term 2, term 3, term 4. So that would be my independent one. And that one always goes on the x-axis or the horizontal axis. The dependent one is the one that changes a little bit more. So our dependent variable is the one output value or the one that's determined or depends on the value that was substituted. Okay? Right. We're going with this as a pattern. All right? So this is a more of an application-y type of question. Huh?
Something smells good. Yeah, distracting.
All right.
Smells like
Why am I getting weird faces about this?
Oh, it's because I'm not good at it.
Oh,
Because I'm distracted.
So, we remember this was on the homework, wasn't it? Yes. So if you looked at your homework, and some of you already handed it in, you'd be great at this. So consider this pattern. So this is our first pattern. This is our second pattern. This is our third pattern. Should be straightforward, yes? So we're looking at these and thinking, right, how are they connected? How are they formed? Madison?
Well, they added 1 to each one.
They've added 1 to each line.
Every time. For the first one? Yeah. Oh, counts.
Try your best, it's hard.
The second one has 3. And the first one is 2, which means they added 1 on to the top one, and then 4, and then 3.
Okay, so if we were thinking about our fourth term, how many dots Fasika would it have on the top? On the top row? 1, 2, 3, 4, 5, and how many dots on the bottom row? 1, 2, 3, 4, 5, 6. And then for our fifth term, n squared?
There would be 6 on top of 7 on the bottom.
6, 1, 2, 3, 4, 5, 6, 7. Okay, oh, that was rubbish. Okay, anyway. So from these 3 diagrams, we complete a table of values and determine the rule. Now, as I've said here, it may help to continue the pattern because sometimes it's not always that obvious. Oh, something went down the wrong way. Now, I said let's call the pattern number n, because that's what we used to call it here. Yes. And I've said the number of dots d. I go all out there with our fancy letters. Okay. Number n and the number of dots is d. Now, which of these two is the independent one? Sarah?
The number?
Yep, the pattern number, yes? So that's n.
Wait, which number? Like the 1, 2, 3, 4?
Yes, the pattern number. Okay? Which means, no prizes here, which is the dependent variable.
The dot.
The dots. Okay, the number of dots.
Depends on the one that changes.
So it depends on it, yes? So it works with the word. So if something depends on something else, it means it's going to be affected by it. Okay? Whereas if we just said the pattern number, that's That's our independent variable, because that's the one that we've chosen, essentially. That makes sense?
Doesn't matter, like if this is just in general, it doesn't always matter if it's lowercase or uppercase.
No. But if a question has given you something as a uppercase, then you should keep it as uppercase.
Okay.
Right, so what I've done here is I've drawn up a little table. Very basic table, yes? I've got N and D. So N, I can see goes 1, 2, 3, 4. I only chose to go up to 4. And D. So what am I going to write for my D? So how many dots were there in total, Maya, for the first pattern? 5. Lovely jubbly. So I just literally put 5. And for my second pattern, that's good, 7. Now, I can see that I've added 2, but let's just double check from our pattern
You've added 2 dots.
if that works. So we see how many we've got here, 4, 5, so that's 9. So pretty much we can see that we're adding 2 each time. So this one would be 11 without actually needing to count it. Yeah? Easy peasy? Right, so I've asked now what's the rule for the sequence. So Georgie, can you explain it and tell me the answer?
So 5, the difference between 7 and 5 is 2. So 2n. And you do 5 plus 2, which is 3. 2n plus 3.
Awesome. So that's our rule. 2n plus 3. So we looked for the difference and we got our,
1,
What?
2n.
because look at the difference between them. Yes?
And we're y plus 3.
Because we say which value would it have been before the 5. So if we were carrying the sequence but this way, backwards, which number would it have been before that?
I missed that part.
Pardon?
It's not in there.
So that's why we wrote it 3. Wait.
I still don't understand.
This is stuff we were doing last
I know,
few lessons.
and I understood it, I understood it but
Okay, where have I lost you? Which bit are you not sure about?
this was plus 3.
Just the plus 3 bit,
Yeah.
okay? Which bit are you stuck on? Okay, so we saw that it was a difference of 2. Yep, so it was 2n. So if we were going to go back to here, we're adding 2 each time. Oh my God. If we're adding 2 each time here, if we were to find the number that would be before it, we would take away 2, wouldn't we? Yes? And that gives us 3.
Oh, that means like a positive thing?
And because we're still in the positive area, it would be a plus 3. Had we gone into the negative values, we would take away whatever the number was. Okay? Does that help now?
Yeah.
Right, okay, once we've determined the rule, you can label the axes and then plot the points as coordinates. Now, you all understand what I mean by coordinate, don't you?
Yeah, it's like
Yes?
it's in the water.
So, we just talked about which one was the independent and dependent, and we said, where does the independent variable go? On the bottom, the horizontal bit. So which of these was the independent?
The number.
The number at the end, the term number, yes? So we would label our axes down here, N, baby N. Okay, we're used to labeling them X and Y, aren't we? But this one's going to be an N. And what am I going to label this vertical axis?
D.
D. Awesome.
Does it matter?
And then,
Does
sorry?
it matter if it comes to the pattern?
No, that's fine.
Wait, no, does it matter which one goes on like what slide?
Yes, it should.
How do you determine this?
We just talked about that, which is the independent and which is the dependent. So the independent one is the one generally it's going to go up in ones. So term 1, term 2, term 3. So that will normally go on the bottom. Well, that will be the one that goes up on the bottom. And then the other one goes in the vertical. So, bless you. I haven't numbered these. I haven't given them a any values on there. You get to choose your scale. I'm just going to go with one of these dashes represents each term number. Now, I've gone all the way up to 10 there. We don't need to.
We only need to go to 4, right?
Secretly, we only need to go to 4 for hours.
So 4 is better. What do we have?
No, you can do, no, you can't do that because you've got a gap of 2, gap of 2, gap of 2, but here you've only got a gap of 1. So if you're going to do a gap of 2, then you would have to start labeling it this one here. Do you see what I mean?
Wait, is it 0?
So here, see here you've got 1, and then you've got 2, 2, 2. So if you're going to label it,
Like I want a space.
so if you want a space, then you would have to start here. 1, 2. That makes sense? All right, and then we have a little look-see, and we've got to go at least up until 11, but probably a little bit more than that because I want to see what goes on afterwards. So we've got to choose a sensible scale. Now, you're not always going to be given the scale, so you have to decide what you want to put on there. So I'm going to go up and choose. Okay, so I'm going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so I've chosen to go up and choose. And then we're going to plot them as coordinates, as I've said. Right, so our first one is 1 and 5.
You
So we-
take it as a box.
No, so we find 1 and we find 5. So 5 is obviously between 4 and 6. And I'm going to put a cross to show that that's my coordinate.
Oh.
Okay, so we're not drawing a bar graph, we're not drawing a line graph, we're just drawing coordinates. Our second value is 2, 7. 2, 7.
It's under 8.
Yes, between 6 and 8, perfect. And then 3 was 9, so 3, 9. And 4 is 11.
You have to draw a line first.
Now, that's a very good question because the next piece of writing says, depending on the situation, you may or may not choose to join the points for the straight line. So, thinking about this one, what would make us join a straight line normally?
Like, you would get like a rule and like, you wouldn't like do it directly on the dot. You would do it like somewhat close to where the dots kind of go.
Right, now you're talking about a line of best fit if your data is not exactly in a straight line. Now, if you were to place a ruler along these, they would be in a perfect straight line, okay? So we could join them up with a straight line, but in this case I wouldn't. And the reason is because are you going to have term number 6.2? No, that's ridiculous, isn't it? Are you going to have term number 4.5?
No.
No. So because you're not going to have a term number in between, then for this one we wouldn't join them up.
Oh.
Okay?
Should we write that? Like that?
Yes, so, I mean, so that's what I've indicated here by saying that you may choose or may not choose to join it up. So maybe write
Is there any
something.
time that we have to?
Well, if we wanted to know what's happening in between things. So, for example, if my pattern numbers had been, well, no. If this was a more practical situation, which I think the one on the back is going to be, then you would join them up. Okay, so if you would, for patterns, no.
I'm confused.
Well, we haven't done the next example yet. Okay? So for this one, I wouldn't join it up because you're not going to be asked about the values in between. Okay? But what we could do is we could continue our pattern, couldn't we? So we could see that our other crosses would go up looking like that. Now, also, if we were to go back down here, where does this pattern cross this axis? What's that value there? Where does this pattern, where does this line cross the axis? Does anyone see? Which value? If I was following my pattern like I did,
It crosses the N and the D axis.
where does it cross the D axis? Where does it cross? Which value is this? Which value is this?
17. 3.
Which value is this?
Oh, I was talking about that.
M squared just said it. What did you say? M squared.
3.
It crosses at 3, doesn't it?
17.
Okay? Remember the axes are here. So
I thought you were talking about where does the N and the D and the N, like which mine doesn't touch at any point if you went down.
now you would have started at 1, 1, 5, yes?
Yeah.
So that's fine, but in the same way that we kept going up in 2s, we could have gone back down in a 2 as well, okay? So if we had placed our ruler, in fact, place your ruler along there. No, I don't, no, not won't be to the musical year, or any straight line.
Oh.
So if you place any straight line along your points, you'll see, huh? No, so you don't have to join up the points, but you can see that it crosses at 3, yes?
Yeah.
And you would be able to find any of these other points up here as well. Yes?
They stop at 8. You stop at 8 because the chart doesn't go at all.
Yeah, yeah. Because anything more than that would be above.
They're stuck in there.
So, do we all see what we did there, yes? Was that challenging?
No.
No? So we filled in our table from our patterns, and we just plotted them as a coordinate. Perfect. Alright, next example. This is a more practical situation. So these are the other types that we might have. Each time when Max has only 10 litres of fuel left in his car's petrol tank, he fills it at the petrol station. That's what people in the UK call a gas station. Petrol. Petrol runs into the tank at 15 litres per minute. The petrol tank can only hold 70 litres. Identify the independent and dependent variables. So let's have a think about this situation. The two things that we're looking at are the
70 liters is a lot. Do most cars hold that much? Lucky I was here.
oh my goodness, it's stuck. Okay, so we're talking about per minute. So we're talking about time. Ooh. Time is one of our variables. And what?
Do cars normally hold 70 liters?
Oh, no, not gallons. So a lot of your cars, some of the gas stations here having gallons.
I was like, I would see like up to 8, maybe not even sometimes.
It's more than that. Right, so we're talking about per minute. So we're talking about time is one of our variables. What do you think the other variable is, Jay? Litres, yes. Good girl. So our other variable is litres. Now, we've got to decide, is time are independent or dependent, and is litres are independent or dependent. So which one of these is going to just essentially go up in ones? So which one of those do you think is your independent variable? N squared? Time, good girl. So our independent variable, so let's write here, independent is time. And there's no merits for this answer. The dependent variable would be
Liters?
the litres.
What if you said it in a different accent? Exactly.
Crazy.
You want to try and test it out though, Sarah?
Alright, it says make a table of values for the number of litres L of petrol in the tank after time t minutes. So, they've told us which letters to use. Which one will I probably put on the top of my table? Remember last time I had my N in the top. Was N the independent or the dependent?
The independent.
So we normally put the independent one in the top of the table. So which was our independent one here? T, which is time. So I'm going to put T in the top. So I'm going to say 1 minute, 2 minutes, 3 minutes, 4 minutes. And then our dependent one is liters. So we'll put L. They've used the capital L. And they told us that petrol runs into the tank at 15 litres per minute. How much are we starting off with though?
10.
10 litres. So we've got to be careful with that. We've already got 10 litres. So after 1 minute, how many litres are we going to have in the tank? So have a think about this. We've got 10 litres already, and we're going in at 15 litres per minute. So how many litres are we going to have after 1 minute, Jade?
25.
Good girl, 25. So I'm going to write here 10 plus 15. Because my 10 was how much petrol I had in the tank. And then 15 was because it was 1 minute.
Oh, so you plus that? I thought you had to times them.
No, so we would add them. So here, for the second minute, I'm going to have 10 litres plus 2 lots of 15. Do you follow that?
Yeah.
So for our second one, we've got 10 litres plus 2 lots of 15. Or in other words,
10 plus 30.
15 more than this.
Oh.
Yes? 10 plus 30, which is 40, yes? Goodness. For our third minute, we would have 10 litres plus 3 lots of 15. So 3 lots of 15 is? In total, it will be 55, yes. And then here we'll have 10 lots plus 10 plus 4 lots of 50. Not 60.
65.
Good. Okay, I'm just gonna.
I didn't know my food was good. Are you recording this?
No good food.
What? Have I not been recording this?
No.
Yeah.
Lots of time.
Alright, so part C says, is the relationship between L and T linear? Well, now, the things that we've been doing up until now have all been linear patterns. Okay? They've been linear patterns because remember the gap between them has always been the same. So we need to have a little look. Is the gap or the difference between them the same?
No.
So what's the difference between 25 and 40? Is Sarah? And what's the difference between 55 and 40?
15.
And what's the difference between 55 and 70?
15. So yeah.
So is this a linear relationship? Is this a linear pattern? Yes.
It's just not laid out like it's supposed to.
So that's important though, isn't it? Because you may have thought the answer quite no, just because it seems too hard. But actually, to work it out or decide whether it is or not actually was quite straightforward. You
But
just
I
have
could
to
have
look.
lost a lot of marks for that.
Well, if you just said no, yes, you would have
It
done.
probably would have been 1 mark.
What does what? I'm confused about like the 10 plus 15.
Okay, because we had 10 litres of gas or petrol in our tank.
You said 15.
No, but look at the very
Oh, okay.
top.
Yeah. I see it.
You understand that? Okay. Part D.
Oh, no, I just see the You just saw the 10.
Alright, so there was 10 litres already in the tank, and then it pumps it out at 15 litres per minute. So after 1 minute, which is what our time is, we're going to have the 10 that was already in there plus 15.
Yeah.
And then after 2 minutes,
Okay.
we've got 2 lots of 15 plus the same, yes?
This kind of really new.
Okay, good. Right, D says, is it sensible to join the plot points graph with a straight line?
No. Yes.
Well, do we want to know how much is in there after 3.5 minutes?
Yeah.
Yeah, you might do, mightn't you? Because you might think you're going to want to stop it halfway. So for this one, we would do. Now, actually, seeing they're talking about joining the points, we haven't actually graphed it, have we?
No.
So I think you've got, should I not give you any graph?
We can draw one. We could draw one.
All right.